Long before humanity ever imagined monsters, before myths, before nightmares, the Earth itself was already experimenting with forms that defy belief. In a remote desert, beneath layers of sun-scorched sediment, a team of paleontologists brushes away grains of ancient dust. What emerges is not merely a fossil, but a skull unlike anything seen in the modern world. Its jaws stretch impossibly wide. Its teeth curve inward like traps. Empty eye sockets stare upward, as if frozen in eternal hunger. This was no ordinary predator. It was something far stranger, something that seems to belong more to imagination than reality. Across deep time, evolution has produced creatures so bizarre, so unsettling, that they blur the line between science and nightmare. These are not myths. They are real organisms, preserved in stone, whispering stories from a world that operated under very different rules. To understand them, one must journey back hundreds of millions of years, into ancient ecosystems shaped by shifting continents, volatile climates, and evolutionary experiments that would never be repeated again. The first of these creatures emerges from the depths of the Permian period, over 270 million years ago. The Earth is dominated by vast deserts and scattered forests, its continents fused into the supercontinent Pangaea. Life on land is still young, but already it is beginning to diversify in strange and unexpected ways. Among the most unsettling inhabitants of this world is Cretaceous. Discovered in Russian sedimentary deposits, its fossilized remains reveal a creature that seems almost assembled from mismatched parts. Its body resembles that of a bulky reptile, yet its skull is adorned with a series of thick, bony protrusions, horn-like structures that jut out in multiple directions. Unlike the elegant symmetry seen in modern animals, these growths appear chaotic, uneven, almost grotesque. Its teeth tell an equally confusing story. Some are sharp and pointed, suited for tearing flesh. Others are flat, adapted for grinding plant material. This suggests a highly unusual diet, possibly omnivorous, making it one of the earliest known large terrestrial animals to experiment with dietary flexibility. But its most haunting feature remains its face. The combination of tusk-like teeth, bulbous skull, and asymmetrical horns creates an image that feels disturbingly unnatural. Yet this was no aberration. It was a product of evolutionary pressures, competition, survival, adaptation, playing out over millions of years. As the Permian world continued to evolve, another creature took shape in the shallow seas. A predator so alien in design that it would later be described as resembling a living chainsaw. Helicoprion. Unlike any shark alive today, this ancient fish possessed a single, spiraled tooth whorl embedded in its lower jaw. For decades, scientists struggled to understand its purpose. Early reconstructions imagined the spiral protruding outward like a bizarre appendage, but more recent fossil evidence suggests it functioned internally, rolling prey deeper into its mouth as it bit down. This adaptation likely allowed Helicoprion to specialize in soft-bodied prey, such as cephalopods, which thrived in the ancient oceans. Its feeding mechanism was not just unusual, it was entirely unique in the history of vertebrate evolution. In the dim, murky waters of the Permian seas, this creature would have been a silent, efficient hunter. Its body streamlined like a modern shark, but its mouth concealing a mechanism unlike anything seen before or since. As the Permian period drew to a close, Earth faced one of the most catastrophic events in its history, the Permian-Triassic mass extinction. Nearly 90% of marine species and 70% of terrestrial species vanished. Yet from this devastation, new forms of life began to emerge. In the Triassic period, the land became a testing ground for evolutionary innovation. Among the dense vegetation and recovering ecosystems, a reptile appeared that seemed almost comical at first glance, until its true nature was understood. Adopodentatus. Its fossil, discovered in what is now China, reveals a creature with a skull that defies conventional anatomy. The front of its mouth flares outward into a hammerhead-like structure, lined with tightly packed, needle-like teeth. Behind this bizarre front edge lies a second row of teeth, forming a filtering system unlike anything seen in reptiles. This structure allowed Adopodentatus to scrape algae from underwater surfaces, effectively acting as one of the earliest known herbivorous marine reptiles. It would sweep its wide jaw along rocks, trapping plant material before filtering it through its inner teeth. In a world recovering from mass extinction, this strange feeding strategy represents a critical shift, an expansion into ecological niches left vacant by extinction. Evolution was not simply rebuilding. It was experimenting. As millions of years passed, the oceans would once again become home to giants, but not all of them followed familiar designs. In the Jurassic seas, another nightmare took form. Liopleurodon. Though often depicted as a massive apex predator, its true size remains debated. Yet even at conservative estimates, it was a formidable hunter. Its body was powerful, its flippers capable of propelling it through water with terrifying speed. But it is the head that commands attention. Its jaws were lined with long, conical teeth, perfect for gripping slippery prey. Its bite force would have been immense, capable of crushing bone. But perhaps most unsettling is the scale of its mouth compared to its body, a cavernous opening that could engulf large prey whole. In the dim light of the Jurassic oceans, where visibility was limited and danger could emerge from any direction, encountering such a predator would have been instantaneous and final. But even Liopleurodon pales in comparison to some of the more unusual creatures evolving on land during this time. In the late Cretaceous, in what is now Madagascar, paleontologists uncovered the remains of a dinosaur that seemed to defy expectations of what a predator should look like. Masiacosaurus. Unlike the sleek, forward-facing teeth of most carnivorous dinosaurs, this species possessed a row of elongated teeth that projected outward at the front of its jaw. These teeth were not designed for tearing large prey, but for catching small, fast-moving animals, perhaps fish or insects. Its skull appears almost distorted, as if evolution had pulled its features forward. The result is a face that looks less like a fearsome predator and more like something assembled incorrectly. Yet this unusual design reflects a highly specialized lifestyle. In a competitive ecosystem, survival often depends not on strength, but on occupying a niche that others cannot. And sometimes that niche produces forms that seem unnatural. As the Cretaceous period continued, another creature emerged, one that would redefine the boundaries of biological possibility. Deep in the ancient forests, beneath towering conifers and flowering plants, something moved with quiet precision. Its limbs were slender, its movements calculated. But its most striking feature was its hands. Each finger ended in an elongated claw, thin, curved, and extending far beyond the length of its digits. Therizinosaurus. At first glance, these claws appear to belong to a predator. They resemble the weapons of a creature designed to slash and tear. Yet evidence suggests that Therizinosaurus was not a carnivore, but a herbivore. Its claws may have been used to pull vegetation closer, strip leaves from branches, or even as a defense against predators. But their sheer size, reaching up to a meter in length, creates an image that is difficult to reconcile with a plant-eating animal. Standing upright, covered in feathers with massive claws extended, it would have appeared less like a dinosaur and more like a living nightmare. And yet, every aspect of its anatomy is grounded in evolutionary logic. Each of these creatures, as bizarre as they may seem, represents a solution to a specific challenge, a response to environmental pressures, competition, and opportunity. They are not mistakes. They are evidence. Evidence that life, when given time and freedom, will explore forms far beyond what we consider normal. That the boundaries of biology are far wider than modern ecosystems suggest. And as paleontologists continue to uncover new fossils from ancient rock layers, one truth becomes increasingly clear. The deeper we look into Earth's past, the stranger it becomes. Because for every familiar form we recognize, there are others, hidden, fragmented, waiting to be revealed, that will challenge everything we think we know about life itself. In the depths of Earth's earliest oceans, long before reptiles dominated the land or giants ruled the seas, life itself was still learning how to exist. The fossil record takes us back over 500 million years, to a time known as the Cambrian period. Here, in shallow marine environments, an evolutionary explosion was underway. New body plans emerged with astonishing speed. Eyes, limbs, armor, claws, structures that would define life for hundreds of millions of years, were first being tested in these ancient waters. But alongside this rapid innovation came forms so alien that they seem almost incompatible with modern understanding of biology. In the Burgess Shale deposits of present-day Canada, paleontologists uncovered fossils that defied classification. Among them was a creature so strange that early interpretations struggled to even determine its orientation. It was named hallucigenia. At first glance, it appears almost abstract, an organism assembled from mismatched anatomical fragments. Its body is elongated and worm-like, but along its back protrude rigid spines, like defensive needles pointing upward into the water column. Beneath it, rows of delicate, tentacle-like limbs extend downward, each tipped with tiny structures that may have helped it grip the seafloor or capture microscopic food particles. For decades, scientists could not even agree which side was up. Early reconstructions mistakenly placed it upside down, with its spines interpreted as legs and its limbs as feeding structures above the body. Only later fossil discoveries revealed its true orientation, correcting one of the most famous errors in paleontological history. Yet even in its corrected form, hallucigenia appears deeply unsettling. Its proportions are unfamiliar, its defenses exaggerated, its entire body plan unlike anything alive today. It represents a world where evolution had not yet settled into stable patterns, where survival demanded experimentation at nearly every level of anatomy. In the same Cambrian seas, another predator moved through the water with far greater sophistication. Anomalocaris. Unlike the fragile, spiny creatures drifting along the seafloor, Anomalocaris was an active hunter, one of the earliest apex predators in Earth's history. Measuring over a meter in length, it possessed a flexible, segmented body that allowed it to swim with precision and speed. At the front of its body were two large, grasping appendages. These were not simple limbs, but highly specialized feeding structures capable of snatching prey from the water column. Beneath them lay a circular, tooth-lined mouth that functioned like a crushing ring, capable of breaking through the exoskeletons of early arthropods. Perhaps most remarkable were its compound eyes, among the most advanced visual systems of its time. Fossil evidence suggests that Anomalocaris had exceptional vision, allowing it to detect movement and track prey in dim underwater environments. In the Cambrian world, where most life was small and defenseless, the emergence of such a predator marked a turning point. Evolution was no longer just about survival, it was becoming an arms race. Defenses evolved, armor thickened, spines became more elaborate, and predators grew more efficient. But this escalation was not limited to the oceans. Millions of years later, during the late Cretaceous period, life on land had reached extraordinary levels of diversity. Forests of flowering plants covered the continents, and dinosaurs dominated nearly every ecological niche. Among them lived one of the most unusual large-bodied theropods ever discovered, Deinocheirus. Its discovery was itself a story of scientific mystery. For decades, paleontologists knew only its massive arms, enormous forelimbs ending in massive claws, first unearthed in Mongolia. These limbs alone suggested a creature of terrifying proportions, leading to widespread speculation about its full anatomy. When more complete fossils were eventually discovered, the truth proved even stranger than imagined. Deinocheirus was not a sleek predator. It was a large, humpbacked dinosaur with a broad body, a duck-like snout, and a long, heavy tail. Its arms remained its most striking feature, oversized appendages that appeared almost disproportionate to its body. Its skull was elongated and low, with a wide beak-like structure lined with small, grinding teeth. This suggests a diet that may have included both plants and small aquatic organisms. Evidence of fish remains in its stomach contents indicates it was likely omnivorous, foraging in rivers and wetlands. Most surprisingly, its vertebrae supported a tall neural spine, forming a hump or sail along its back. The function of this structure remains debated. It may have been used for fat storage, display, or thermoregulation. Whatever its purpose, the result was a creature that seemed assembled from multiple evolutionary experiments, each part serving a different ecological function, yet forming a single, cohesive organism. In its environment, Deinocheirus would have moved slowly along riverbanks, using its enormous claws to dig, grasp, or sweep through vegetation. Despite its awkward proportions, it was clearly successful, thriving in ecosystems shared with some of the most iconic dinosaurs in history. As the Cretaceous continued, another group of dinosaurs evolved in a very different direction, one that emphasized speed, agility, and sensory adaptation. Among them was a small but highly specialized predator, Masiacosaurus. Its most defining characteristic was its forward-projecting teeth, which extended outward from the front of its jaw like a series of pointed spikes. Unlike the typical serrated teeth of theropods designed for slicing flesh, these teeth suggest a very different feeding strategy. Paleontologists believe Masiacosaurus may have targeted small, fast-moving prey, fish, insects, or other small vertebrates. Its unusual dental structure would have allowed it to grip slippery prey with precision, preventing escape. Its body, relatively lightweight and agile, suggests a creature adapted for quick movement through dense vegetation or along coastal environments. In a world dominated by larger predators, specialization became its survival strategy. But perhaps one of the most visually striking creatures of the entire Mesozoic era was not a predator in the traditional sense at all. It was a herbivore whose defensive adaptations created one of the most visually dramatic forms in dinosaur evolution. Therizinosaurus. Although already introduced in earlier discoveries, its significance becomes even clearer when viewed within the broader context of evolutionary experimentation during the Cretaceous period. This enormous dinosaur stood on thick hind limbs, with a body likely covered in primitive feathers. Its head was small, with a beak-like mouth adapted for browsing vegetation. Yet its arms defied expectation. Each hand bore elongated claws reaching extraordinary lengths, curved, blade-like structures that extended far beyond the animal's fingers. These claws were not tools of predation, but instruments of interaction with its environment. They may have been used to pull down branches, strip leaves, or defend against large theropod predators such as Tyrannosaurus. Their sheer size, however, created an image of contradiction. A peaceful herbivore armed with weapons that appear almost exaggerated in design. In life, Therizinosaurus would have been an imposing presence within its forested habitat. Not because of speed or aggression, but because of its sheer, uncanny appearance. A creature whose anatomy challenges instinctive expectations of what a dinosaur should look like. And yet, like every organism revealed through the fossil record, it is not an anomaly. It is a product of adaptation. Across these vastly different time periods, from Cambrian seas to Cretaceous forests, a consistent pattern emerges. Life does not follow a single blueprint. It diverges, experiments, and reshapes itself in response to environmental pressure. What appears bizarre or unsettling to modern eyes is often simply the result of evolutionary pathways that no longer exist. Each of these creatures represents a chapter in that ongoing story, a story written not in imagination, but in stone. Deep within the layers of Earth's geological memory, there are still chapters of prehistoric life that continue to reshape scientific understanding. Even today, paleontologists uncover fossils that do not merely add details to known species, but introduce entirely new forms of life that challenge long-held assumptions about evolution itself. The final stretch of this journey through Earth's strangest prehistoric creatures brings us into worlds where mammals begin to rise, oceans remain dominated by apex predators of unimaginable scale, and ecosystems approach the threshold of modern reality, yet still retain echoes of ancient experimentation. One of the most unsettling discoveries from the late Eocene epoch comes from the ancient coastal deposits of what is now Pakistan. Here, in sediments once part of a warm, shallow sea, scientists uncovered the remains of a creature that would have ruled these waters with absolute dominance, Basilosaurus. Despite its name suggesting a reptile, this was in fact an early whale, an evolutionary bridge between land-dwelling ancestors and modern cetaceans. Its body, however, bears little resemblance to today's whales. It stretched over 15 meters in length, serpentine in form, with a narrow skull lined with long, piercing teeth. Unlike modern whales that rely on filter feeding or echolocation, Basilosaurus was a fully active predator, hunting large fish, sharks, and even smaller whales. Most disturbing to early paleontologists were its vestigial hind limbs, tiny, almost useless legs embedded within its body. These remnants serve as direct evidence of its terrestrial ancestry, frozen in evolutionary transition. They are not functional in locomotion, yet their presence is undeniable, a biological echo of a time when its ancestors walked on land. In the ancient Tethys Sea, Basilosaurus would have moved like a living weapon, its elongated body undulating through warm waters with lethal precision. It represents a moment in evolutionary history where life had not yet fully committed to its new form. It was becoming something else. But the oceans of the Mesozoic still held even greater nightmares. During the late Cretaceous, approximately 80 million years ago, the seas were home to one of the most powerful marine predators ever to exist, Mosasaurus. Unlike earlier marine reptiles, Mosasaurus was fully adapted to ocean life. Its limbs had transformed into flippers, its tail into a powerful propulsive fin. Its body was streamlined for speed, allowing it to ambush prey with devastating force. Its skull was filled with rows of sharp, conical teeth designed not for chewing, but for gripping and swallowing prey whole. Fossil evidence suggests it was an opportunistic predator, consuming fish, ammonites, other marine reptiles, and even smaller mosasaurs. What made Mosasaurus particularly formidable was not just its size or strength, but its jaw structure. Its skull contained flexible joints that allowed it to swallow large prey in a single violent motion. Once captured, escape was nearly impossible. In the chalk seas of the late Cretaceous, Mosasaurus occupied the role of ultimate apex predator. Even other large marine reptiles would have avoided confrontation with it. Its dominance was absolute, its ecological niche unchallenged. Yet while the seas were ruled by leviathans, the land was undergoing its own transformation, one that would eventually reshape the entire planet. In the Paleocene and Eocene epochs, following the extinction of non-avian dinosaurs, mammals began to diversify rapidly. New forms emerged, filling ecological roles once occupied by dinosaurs. Among these early mammals were creatures that seemed almost like evolutionary experiments in gigantism and specialization. One such example is Andrewsarchus. Known primarily from a single skull discovered in Mongolia, Andrewsarchus is one of the most mysterious mammals ever identified. Its skull alone measures over 80 centimeters in length, equipped with large, powerful jaws and robust teeth capable of crushing bone. The exact appearance of its body remains uncertain, but scientific reconstructions suggest a heavily built, wolf-like predator, possibly semi-aquatic or adapted to scavenging and hunting large prey along river systems. Its ecological role may have mirrored that of later apex predators, yet its evolutionary lineage is entirely distinct. It represents a time when mammals were still exploring the upper limits of body size and predatory specialization. In a world still recovering from extinction, Andrewsarchus stands as evidence of rapid evolutionary expansion, where ecological opportunity allowed mammals to experiment with forms that would later vanish as ecosystems stabilized. But not all strange prehistoric creatures were massive predators. Some were small, fragile, and deceptively unusual in structure. During the Miocene epoch, a tiny mammal emerged in the forests of Europe whose anatomy would later surprise scientists studying its fossil remains. Tilocercus, the pen-tailed tree shrew. At first glance, it appears unremarkable, but its elongated tail, tipped with a feather-like tuft of hairs, sets it apart from most modern mammals. This adaptation is believed to aid in balance and agility as it navigates complex arboreal environments. While not monstrous in scale like other creatures in this documentary, its significance lies in its evolutionary placement. It is closely related to early primate lineages, offering insight into the early stages of mammalian diversification in forest ecosystems. Its delicate anatomy reflects a different kind of survival strategy, one based not on dominance, but precision, agility, and ecological specialization. Across all these epochs, from the Eocene seas to Miocene forests, a consistent theme emerges. Evolution does not move toward perfection, but toward adaptation. Sometimes, this process produces giants like Mosasaurus, creatures engineered for dominance in ancient oceans. Other times, it produces transitional forms like Basilosaurus, suspended between two worlds. And at times, it produces anatomical anomalies like Androsarchus, whose fossil fragments hint at forms still not fully understood. But the story of Earth's strangest creatures does not end in the deep past.